Today I am going to explain the first chapter, the real numbers. You all know real numbers. All rational as well as irrational numbers together make real numbers. I am to start with Euclid's division lemma. And what is this Euclid's division lemma? Given two positive integers, a and b, there exist positive integers q and r such that a is equal to bq plus r and r lies between 0 and b. Now let me write here, given two positive integers a and b, there exist positive integers q and r satisfying a is equal to bq plus r, where r lies between 0 and b. Now, let me explain this. We have two positive integers a and b. A is greater than b. Divide a by b. You will get one quotient and you will get one remainder. Now, this is dividend. This is divisor. This is quotient. And this is remainder. He says, given two positive integers a and b, there exist positive integers q and r satisfying a is equal to bq plus r. Now here a is equal to bq. We multiply this with this quotient. We multiply divisor with quotient and we add remainder in this. We will get a. And this remainder is always less than this b. Remainder can be 0 and remainder is always less than b. It means remainder lies between 0 and b. Remainder can be 0 also, but remainder is always less than this divisor. Now, if I take one example, take the number 13, divide by 2. 2 6 are 12. You will get 1. It means 13 is a, this is b, this is q, this is r. So 13 is equal to 2 into 6 plus 1. It means a is equal to, this is b, this is q, and this is r. So you can understand this now. Now, Euclid division lemma, this is Euclid division lemma. Let me repeat it. Given two positive integers a and b, there exists positive integers q and r satisfying a is equal to bq plus r and r lies between 0 and b, and there is equality sign with 0. On the next page, I am going to explain Euclid division algorithm. Now the question arises, what is the difference between lemma and algorithm? And second question is, what is the definition of Euclid's division algorithm? Now, on the next page, I'll give the answers. First, Euclid division algorithm. Now, Euclid division algorithm is a technique to find the HCF of two positive integers a and b. Let me write it here. Now let me repeat it. Euclid's division algorithm is a technique to find HCF of two positive integers. Now lemma. What is lemma? It is a proven statement which is already proved, and we use that statement to prove another statement. It is a proven statement and it is already proved statement, and we use that statement to prove another statement. It is already proved statement and we use that statement to prove another statement. So it's already proved statement and we use that statement to prove another statement. That is lemma. And algorithm, it is a series of well-defined steps which gives a procedure for solving a type of problem. It is a series of well-defined steps which gives a procedure for solving a type of problem, which gives us a procedure for solving a type of problem, for solving a problem. Let me repeat it. Algorithm is a series of well-defined steps which gives us a procedure for solving a problem. This is already proved statement, and this is a series of well-defined steps which gives us a procedure for solving a problem. I'll give you an example. It will be more clear to you then. एक बार मैं आपको हिंदी में समझा देती हूँ. लेमा क्या है? लेमा एक ऑलरेडी प्रूव्ड स्टेटमेंट है और उस स्टेटमेंट का हम दूसरी स्टेटमेंट को प्रूव करने के लिए यूज करते हैं. एल्गोरिथम क्या है? वो आपका किसी भी सम को सॉल्व करने के लिए उसके जो स्टेप्स होते हैं वो एल्गोरिथम कहलाता है. अब आगे बात यूक्लिड डिवीजन एल्गोरिथम. यूक्लिड डिवीजन एल्गोरिथम क्या है? ये आप दो पॉजिटिव इंटीजर्स हैं, उनका जो एचसीएफ निकालना होता है उसके लिए जो स्टेप्स आएंगे वो यूक्लिड डिवीजन एल्गोरिथम होगा. नाउ आई थिंक इट्स क्लियर टू यू नाउ. सो नेक्स्ट पेज I'll give one example. I'm going to take the same example which is written in the book. Now I'm going to explain one example. Use Euclid's division algorithm to find HCF of 455 and 42. So we are using Euclid's division algorithm to find the HCF of 455 and 42. Here A is 455 and B is 42. Here A is greater than B. By using Euclid division lemma, we will have 455 is equal to 42 into 10 plus 35. Now here 35 is not equal to 0. So use Euclid division lemma on 42 and 35. So we will have 42 is equal to 35 into 1 plus 7. Again, 7 is not equal to 0. Remainder is not equal to 0. So again use Euclid division lemma on 35 and 7. 35 is equal to 7 into 5 plus 0. So here remainder is 0. So it implies HCF is 7. So HCF is 7. This is how we use Euclid division algorithm to find the HCF of two numbers. Sometimes it is difficult to use mental calculations. So you can take the help of this method. 455 divide by 42. 42 ones are 42. This is 3. This is 5. 42 0 0. This is 35. Now 35 is less than 42. So now 42 is the dividend. 35 ones are 35. This is 7. Now 35 is the dividend. 7 is the divisor. 7 5s are 35. 0 is the remainder. So if sometimes if you find it difficult to use mental calculations, then take the help of this method. Now example 2 is show that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1. Now this is a very important statement, and you know every positive integer is of the form 2q and every odd positive integer is of the form 2q plus 1. First try to understand this, what's its meaning is. Now when a number is even, if we divide by 2 and its remainder is 0, then it is an even number. When we divide a number by 2 and its remainder is 1, it's an odd number. So whenever we ask this question, give a definition of an even number. What you say? Divide a number by 2. If it is divisible by 2, it's an even number. If it is not divisible by 2, it's an odd number. So 2, 4, 6, 8, they are even number. 1, 3, 5, they are odd numbers. Now let me give an example. Take a number 14, divide by 2. 2 sevens are 14. Remainder is 0. It means this is an even number. Another number 15. Divide by 2. 2 sevens are 14. And remainder is 1. So this is an odd number. So 14 can be written as 2 into 7 plus 0. It means 14 is equal to 2 into 7. It means 14 is A and 2 and this is Q. This number is A. This is B. This is Q. So here 14 is A, B here is 2 and 7 here is quotient. So 2Q. A is equal to 2Q. So a even number is of this form. Let me write this odd number. So 15 is odd number. This is equal to 2 into 7 plus 1. So this is A and 2Q plus 1. So if a number is written in the form of 2Q plus 1, so this is an odd number. So this is the question. I'll explain it here, how you are going to write it in the exam. So show that every positive integer is of the form 2Q. Let A and B are two positive integers. So A and B are two positive integers. And here B is equal to 2. Because we have to see whether they are even or they are odd. So there exist positive integers Q and R satisfying A is equal to 2Q plus R, where R lies between 0 and 2. Value of R should be between 0 and 2, and it can be 0 also. It means value of R can be 0 and can be 1. If R is 0, it means A is equal to 2Q plus 0. It means A is equal to 2Q. If R is 1, then A is equal to 2Q plus 1. So A is equal to 2Q plus 1. So if remainder is 0, it is an even number. An even number can be written in the form of 2Q. And if R is 1, it is an odd number. An odd number can be written in the form of 2Q plus 1. So this is how you will write it in the exam. Even number can be written in the form of 2Q and odd number can be written in the form of 2Q plus 1. So that is the question. And always remember, even number can be written in the form of 2Q and odd number can be written in the form of 2Q plus 1. I'm going to repeat this line again and again. So please try to remember this. Example 3 is, show that any positive odd integer is of the form 4Q plus 1 or 4Q plus 3, where Q is some integer. Let A and B are two positive integers. Here we will take B as 4. There exist positive integers Q and R satisfying A is equal to 4Q plus R, where R lies between 0 and 4. Now, if R is 0, then A is equal to 4Q. If R is 1, A is equal to 4Q plus 1. If R is 2, A is equal to 4Q plus 2. If R is 3, A is equal to 4Q plus 3. R cannot be equal to 4. So R is always less than 4. So value of R can be 0, 1, 2, 3. Now, see which one is even and which one is odd. Let us check. Now 4Q. This can be written as 2 times 2Q. And 2 times 2Q, I can write it as M. So this is equal to 2M. And this is divisible by 2. So this can be written as 2 times 2Q plus 1. So here I have taken 2Q as M. Now, if I take 2Q as M, so this is written as 2M plus 1. And we know if a number is written as 2m plus 1. This is an odd number. Similarly, take 2 common here. So this is 2q plus 1 in the bracket. If I take 2q plus 1 as m, so this is 2m. Again, this number can be written as 2m. So this is an even number. And this number 4q, bifurcate 3 as 2 plus 1. Take 2 common from this bracket. So you will have 2q plus 1 plus 1. This is 2m plus 1. Here I have taken 2q plus 1 as m. So this is 2m plus 1 is an odd number. It means 4q plus 3 is an odd number. No doubt you will find it difficult in the beginning, but after some time, after doing a few sums, you will find it easy. Read the statement properly. What it says, show that any positive odd integer is of the form 4q plus 1 and 4q plus 3. Odd integer. We are to check which are odd numbers, which are even numbers. Now, here, this is an odd number. This is an odd number. Odd numbers is of the form 4q plus 1. Odd number is of the form 4q plus 3. So we have first check which are odd numbers, and then we will say odd numbers are of the form 4q plus 1 and 4q plus 3. So let me repeat this again. Now see here, this is 4q. 4q, you can write it as 2 into 2q. 2q is m. So this is equal to 2m. When this is equal to 2m, it is an even number. If 4q is equal to 2m, then it is an even number. Now here 4q plus 1. So 4q can be written as 2 into 2q. We can write it as m or n or anything. So this is 2m plus 1. And 2m plus 1 means it is an odd number. 4q plus 2. Take 2 common. 2q plus 1 in the bracket. Write it as m, where m is an integer. So this is equal to 2m. Again, this is an even number. So 4q plus 3, bifurcate 3 as 2 plus 1. Then you will take 2 common. It is 2q plus 1 in the bracket, plus 1. Write it this as m. So this is 2m plus 1. So this is an odd number. So positive odd integer is of the form 4q plus 1, 4q plus 3. Any odd integer is of the form 4q plus 1 and 4q plus 3.